Hello, you good humans. Welcome back to our video tutorial session on how to draw a cube. This session, or this tutorial, is going to focus on how to take a cube that we've drawn in model space, which is a virtual environment, and convert it to a drawing that we can print out. So what we're basically going to do is get ready to configure our workspace and our layouts in such a way that we can actually print out something that we've drawn. I'm going to use the cube that we drew in a previous session as the model, and we're going to go ahead and make some changes to our layout environment that enables us to print out our drawing. Now, there are some very specific things we need to do in order for you to meet the objectives of the Drawing 2 module as part of your National Diploma Civil Engineering. Remember that we are technicians that draw. We're not pretending to be draftsmen per se, so we're going to follow a methodology that is going to work for us. So the first thing we need to realize is that this cube has been drawn in model space, and as part of our curriculum we do not print drawings from model space, although other people do it, and you can do it. If you know what you're doing in industry one day, maybe try it. I don't recommend it. I think the best convention for us is to print our drawings from the layout environment, or the paper space environment as it were. So how am I going to go about doing it? What are the steps or the processes I might follow? Well, because this is a fairly small drawing, I only have this one cube, I'm going to choose in a premeditated way to select an A4 drawing page. So let's say I need to produce an A4 drawing, and I need to draw this cube at a scale of 1 in 1000. How might I go about that? What are some of the steps I might take? Well, what you need to do first of all is to identify that you are not going to be not be printing from model space, but you're going to be printing from the layout space, or paper space as it's called. So let's go ahead and select layout 1, which is going to take us into the paper space environment. While I am in model space now, just take note that the model space tab is active, and at the bottom right hand side of the screen you will see a little button here that says model. Take note of how that changes. So I'm now going to go left click on layout 1, and you will see that I have a virtual page. The black area, the dark area, is a representation of a piece of paper. The dashed white lines represent the printable area, and this red border that I have around is the viewport. The viewport is the window that I have from my now paper space environment into my model space environment. So if I click on the viewport, I'm able to see some information, but more than that, I can interact with it by making it bigger or by making it smaller. The viewport, as I said, is a window that we have into the model space environment. It has certain properties. One of the properties that it has is you can choose to either have it locked or unlocked. Now, if the viewport is locked, I'm able to interact with the model space environment through my viewport, but I'm not going to be able to make any changes to either the scale by using the dynamic pan function, or by shifting the drawing space around behind the window. What does that mean? Well, let me double left click inside the viewport now, and you will see that the viewport becomes active. Please note how it is now bold, and then the model space dialogues are appearing inside. If I now double click again with the roller button, double click on the roller mouse, you will see that, well, you won't see anything as it were by the look of things. What's going on? Okay, I'm going to zoom out a bit, and there you will see my cube is in there. I'm zooming in and panning using dynamic functions, and you can see that as I zoom in with the roller and zoom out, that the cube is changing sizes. Now, if it's changing sizes, effectively it's changing scale on my paper layout. So you'll notice now that the viewport is active. If I now want to make sure that it's inactive, I can come down to the bottom right hand side of my screen and click on where it says model, and you will see that the viewport is now deselected. I was able to do all of those things because the viewport was unlocked. If I select my viewport and right click, you will notice that a window pops up here, and one of the items listed here is display locked. You'll see that currently it is checked for no. If I say yes, then my viewport is locked, If I double click inside my viewport now, the viewport is active, but if I pan, if I zoom in or zoom out, you'll notice that I'm zooming in and out on my whole page and no longer only in the model environment. In order for me to configure my workspace set scales on my viewports, it needs to be unlocked. So that's just something useful that we can think about for future use. I'd also like to show you that you can also copy your viewport if you wanted to by using the copy function. So I can select my viewport and create a copy of it, and then obviously I can resize it in order to fit the space that I'm working in. And because of locking and unlocking viewports, I can set different viewports to different scales, and I can zoom in and out on different parts of my model space environment on a single page. I apologize for the poor sound and quality, but I am connected to AutoCAD via VPN and my connection is not very good at the moment. As for the audio, I don't really know what to do about that. Alright, so let's make the assumption that I have just clicked on the layout tab, and in fact let's just go ahead and delete these two viewports, and I'm just going to go straight onto layout 2, show you how to configure the layout environment. Right, so this is what I get when I click on layout 2. You'll notice that I have the viewport, I have the page, and I have the printable area. In order to get started, I recommend that you right click on the layout tab and we go to the page setup manager. Let's select that. With the page setup manager selected, I'm going to go to the modify button. Please remember these steps, they're very important for your tests. And this page setup layout 2 manager pops up. I need to make some very specific changes here in order to meet the requirements of the course. So one of the things I need to do is to assign a plot style. The plot style that you're going to use is one that will be emailed to you, and it will be the S4 NMMU project plot style. You don't have it at the moment, but I will show you in a later video tutorial how to install it. So I'm going to go ahead and install mine because it's already set up on my computer. So this is something you must definitely look for, this NMMU S4 project plot style, and it must be selected. For goodness sake, do not click on this button, display plot styles. Next, we need to select a printer. The printer that we're going to use for most of our purposes in this module is the drawing to PDF plotter, which enables us to convert our drawings to PDF drawings, which we can then email as part of our assessments. So drawing to PDF.pc3. Page size. The page size that we're going to select in this case, I said was going to be A4, but let's be bold. Let's use something different. Let's go with A3 just to make it a bit more interesting. I'm going to go on the little arrow and I'm going to look for the ISO A3. That's the one. And what to plot in the plot area? We're always going to start off by clicking layout. There are other options, display, extents and window. We'll talk about those at a later date, but for now let's use the layout button. Plot scale, this is critical, don't get this wrong. For our purposes and for the majority of design offices that you find yourself in, certainly in our environment in Port Elizabeth, South Africa, we are going to use a scale of 1:1. So 1 millimeter equals 1 unit. Remember, this is for the paper space environment. So when I measure in paper space, 1 unit is going to represent 1 millimeter, or 1 millimeter is going to represent 1 unit in my drawing environment. Alright, you need to start thinking about that in advance. Remember, I'm drawing in meters, this is in millimeters, so if I have a 1:1 scale, I think, if I'm not mistaken, we're going to have a scale of 1 in 1000. Good. That's all the changes we need to make here. Please take note that this drawing is in landscape. You can obviously change it to portrait if you want to, or even upside down if needs be. So I'm going to go ahead and say OK. Once I've said OK, I'm going to say close. And notice that the page size has now changed. For practical purposes, we need to change the size of this viewport. One way is to click on it and to stretch it out to the size that you need it. Another way of going about it is simply by deleting it, and this is a method that I prefer to use. Deleting it, and we're now going to create a viewport. Now this function is very easy. We're going to type in a command, and the command we're going to type in is mview. So mview, enter, and now I can simply specify the size of my viewport. I don't have to have one, I can have multiple, I can use as many as I want, but I'm just going to use it for this example. Left click at the bottom of the page, and there is my viewport. Notice that if I double click inside the viewport, let's try it again, 1, 2, 3, double click, active command, that was silly. Okay, let's try again, double click, yes, we are there. The viewport is now active. If I zoom in and out with the roller button on my mouse, you'll see that the cube changes in size. If I hold down the roller button and pan left and right, you'll see that the cube moves. I want to now go ahead and set some kind of scale on this. I'm going to try and set a scale of 1 in 1000. Remember, my model space is in meters, my paper space is in millimeters, so 1 meter in model space represents 1 unit in paper space. And if the unit is 1 meter and it's 1 millimeter here in paper space, then I have 1000 millimeters in model space and 1 millimeter in paper space. And if I divide the model dimension of 1000 millimeters by my paper dimension of 1 millimeter, I get a scale denominator of 1000. So that's going to be what I'm looking for. In order to achieve a scale of 1 in 1000, I'm going to type in some scale commands. And the commands I'm going to type in, make sure that you are in model space. Check on the bottom right here. And the command I'm going to type in is Z, enter, S, enter, and I'm going to choose a scale factor of 1 XP. Push enter, and you notice that my drawing space has changed a bit. I'm going to click on the model button to change to paper. I'm going to lock the viewport for demonstration purposes. Okay. Now, if I double click inside the viewport, you'll notice that the page is moving backwards and forwards, not my cube. And if I try and pan, then it only pans to the left and right. So the cube is in place because my viewport is locked. If I now want to measure one of these sides in paper space, make sure you select paper space. My version of AutoCAD is using annotative dimensioning, which means it's going to measure through paper space into model space. So if I want to measure the length of this line, what I recommend you do to be safe is just to draw a line over that line in paper space, not in model space. So I'm going to choose the line button. I'm going to draw a line from the top to the bottom. And if I measure this line by left clicking on it, I've got a length of 20 units. Now remember, that is 20 millimeters because I'm measuring in paper space. I know that it is actually 20 meters long in model space, and I therefore know that the scale denominator is going to be 20 meters divided by 20 millimeters, so 20,000 millimeters divided by 20 millimeters is going to be a scale of 1 in 1000. Let's try that again. Let's see what happens if I change the scale factor. So the first thing I need to do is to unlock the viewport by right clicking display locked. No. Double click inside the viewport to make the viewport active. Notice that I can now zoom in and out. I'm going to type in a command Z, enter, S, enter. Instead of 1 XP, I'm going to choose 2 XP. And you'll notice that I was able to create a slightly bigger cube. Be careful when you're interacting not to zoom in and out with the mouse, because you will then obviously, if I zoom in and out, I'm going to change the scale. So let me type that command in again. Z, enter, S, enter, 2XP, enter, and there is my cube. I'm going to make sure that I'm clicked into paper space. I'm going to lock my viewport. I think my dogs are about to bark. I think somebody's at the gate. Please ignore them. They don't bite, but they do make a lot of noise. Okay, so I now want to measure this length of this line. I said the best way to do it, because of the annotative dimensioning, annotative measurement, was to draw a line from from the top there to the bottom, enter. I can left click on the line and I see the length is 39.893. Let's ask ourselves why it is not something else. Did I make a mistake here? Let's have a look. Notice that I didn't extend the line all the way to when I drew it. I made a mistake, so let me extend this line now. Whoa. Let's select it. Make it go right down to the bottom. There we go. And you see the length is, in actual fact, 40. Let me just move this guy here while we're here for the sake of completeness. Oh wait, I can't because that line is in model space. I'm in paper space. Let me choose model space. Move that guy down there. Good. Let me go back to paper space. There we are. So if I zoom out, click on the line, those dogs are really making a noise. Anyway, length 40. So if I now do the calculation on the scale of this drawing, I've got to say 20,000 millimeters divided by 40. Let's see what that is. Do I have a calculator? So 20,000 millimeters divided by 40 millimeters, which is the actual length in paper space, and I see that I then have a scale of 1 in 500, which is quite a normal scale to use in civil engineering drawings. So I've now created a scale of 1 in 500 by using the command 2xp as opposed to the command 1xp, which gave me 1 in 1000. Good. Well, am I ready to print? Well, let me first delete this line that I created in paper space. I now have my page set up. You would typically have a title block, north arrow, all the bits and notes that you would need, the rest of the drawing as it would have been drawn. Let me now try and print this drawing by using the PDF printer. I select the plot, right click, and you will notice this interface. You will have recognized it from a previous portion of the tutorial. Note that sometimes the right hand side portion of the display is not shown. There's this little arrow at the bottom sometimes, which can be a bit of a problem. You might end up opening up this layout, plot layout screen. The plot style is found by expanding the view, and you can please take note that we have to have the correct plot style assigned. Plot style talks about pen settings and line weights, so that's important. Drawing to PDF, that's the plotter that I want to use. The drawing size ISO A3, layout, scale 1:1, landscape. We can now do a quick preview by clicking on the preview button, and this is how my drawing is going to appear once it has been printed. Very useful function. You'll be able to look and check over various aspects of your drawing, but for the best checking of drawings you need to actually plot it out. So I'm going to right click now, and I'm going to choose the plot button. Please take note that what's happening with the PDF plotter is it now wants you to select or specify a path where you're going to plot your drawing to. As part of your submission, you are going to need to email this PDF file to your lecturer, so make sure that you follow or at least know exactly where you have pasted this file. I recommend that you either paste it onto your flash drive or onto your shared documents file or onto the desktop. So I'm going to go with the desktop, and I'm going to give this drawing file a name, and I'm going to call it the cube. In the test environment, you must please follow the instructions provided on the question paper. It'll specify how you must name your file, typically with your student number, surname, and then the drawing title. But look for that on the test paper. Save. And here is the PDF viewer of what your cube looks like. Good, that was easy. I hope you found this video tutorial useful. There were a lot of tips and tricks here. Please make sure that you are able to carry out the various commands and procedures that we've done in this video. They will be very important to you in passing certainly test 1 of the module drawing 2 for the National Diploma Civil Engineering. Thank you for your time.